Fume extraction cabinets, or fume hoods as they are sometimes referred to, are safety devices and should comply with the following international safety standards: ANSI ASHRAE 110-1995 and EN 14175. The EN 14175 European standard supersedes the former national standards of Germany, United Kingdom and France. The key factor which differentiates EN 14175 from ASHRAE 110 standard is the robustness test, which simulates airflow disturbances in front of the fume extraction cabinet and its ability to retain contaminant in the presence of such airflow disturbances. In order to prove compliance to international safety standards, it's mandatory to conduct a type test which proves that the design and construction meets the extremely demanding challenges of harmful fume containment and extraction in operation. In all first world countries, it is a statutory requirement for producers to prove performance and safety by having an independent and internationally accepted test institute test their fume extraction cabinet design and issue a test certificate of compliance. There are two questions that every end user in South Africa should be asking. 1. Can I really trust and rely on the protection of personnel and containment of harmful fumes in the absence of an international safety test certificate? 2. Does the absence of a statutory requirement for international safety test certificate in South Africa absolve us from the responsibility to demand safety for personnel? The answer is obviously no, because legislation states that every employer shall provide and maintain, as far as reasonably practicable, a working environment that is safe and without risks to its employees. Now that we've established what the statutory design requirements for fume extraction cabinets are, join us on a journey through the FiltaMatix quality process to see why we are considered as the market leader for fume extraction cabinets, biological safety cabinets, laminar flow benches, chemical storage cabinets, laboratory furniture, and solid surface workstations. FiltaMatix fume extraction cabinets are fully compliant to the following international safety standards and is the only South African product which has international safety test certification to the American standard referred to as ASHRAE 110-1995 and the European standard referred to as EN 14175. This state-of-the-art safety device has been designed by using computational fluid dynamics for improved airflow uniformity and maximum containment and extraction. Each component, which could negatively impact on performance or contribute to turbulent airflow patterns, has been subjected to test and redesign before being declared fit for the purpose intended and approved for manufacture. The end result is a low-flow and energy-efficient saving device with uncompromised safety features. What differentiates FiltaMatix fume extraction cabinets from competitor products? Safety, reliability, and ergonomics without compromise due to the following engineering features. Aerodynamic airfoil. The positioning and design of the airfoil creates a gentle and uniform airflow across the work surface, which guides the contaminant towards the rear extract zone. A purpose-made swivel action creates operator comfort and acts as an armrest whilst working in the cabinet. When the sash is closed, air will enter the cabinet from openings under the airfoil and continue to be extracted to avoid fume buildup in the work zone. In order to develop and test the airfoil, airflow simulation techniques were used. Note how the airflow pattern changes when the velocity and positioning is compromised. The FiltaMatix design is an engineering accomplishment which enhances performances. The work surface and cabinet interior design. The most popular choice for the work surface is a solid epoxy base with excellent chemical compatibility as well as heat-resistant qualities to greater than 300 degrees Celsius. Load tests prove that heavy-duty equipment, including lead shielding blocks, can be used without deforming the base. The epoxy work surface is completely non-porous and will therefore not allow chemicals to penetrate through the solid surface. Damage and scratch marks can easily be repaired, providing unprecedented lifespan. The molded solid epoxy base has three remarkable features, which are a spill retention cavity to contain chemicals during accidental spillages, a retaining barrier which forces the operator to work deep enough into the work zone and in so doing prevent fumes from exiting through the sash opening, drip cups to facilitate fluid draining to waste. Stainless steel options are available for specific applications such as perchloric acid cabinets with built-in washdown systems and drain trough, radioisotope applications. Polypropylene or unplasticized PVC and ceramic may be selected for specific applications. The sash design. The sash has been designed from safety glass and is contained in a polypropylene perimeter frame connected to an aerodynamic sash handle. The sash handle, complete with smooth air entry shape, does not impede visibility in any way. The sash is installed and supported by a chain and sprocket system, interconnected with a counterweight design for smooth and maintenance-free operation. The counterweight balance is so designed that it automatically returns to the set point opening level without operator intervention. This ensures that the sash is never left at opening levels, which may reduce the intake velocity and result in fume discharging from the work zone. Provision has been made to open the sash to maximum levels when loading large equipment and to close the sash during the periods of operational interruption or when the cabinet is not being used. Slotted baffle system. Strategically designed and placed baffles are fitted into the work zone to provide a smooth extract passage for fume-laden air. The slotted portion and dimensionally precise perimeter exhaust passage offers excellent heat and fume displacement and prevents excessive turbulence which could otherwise result in eddy airflow patterns. Such conditions could cause contaminant release, placing personnel at risk due to chemical exposure. Electrical termination. All the electrical components are pre-wired and connected to a dedicated electrical distribution box, SABS approved, or proven international components have been selected. A certificate of compliance is issued with each cabinet and an electrical drawing is provided as standard. Fume extraction cabinets should be connected to an emergency power system for backup in the event of power failure. This will ensure that fumes continue to be exhausted until such time as the power has been restored. Emergency power circuits should be made available for the fan to restart automatically upon restoration after a power outage. The lighting. The fume hood lighting is pre-wired, energy efficient and electronically ballasted. The instant start feature with a light intensity on the work surface of greater than 1000 lux in zero ambient conditions provides excellent visual properties to work safely. The fluorescent light casing is not secured to the superstructure and acts as an explosion relief. During accidental explosions and for additional safety, the upward pressure will dislodge the fluorescent light casing to protect the operator. Light fixtures and electrical outlets can be replaced from outside of the fume hood. A transparent and impact-resistant vapor-tight shield shall be included to prevent chemical contact with the light-fitting components. The exhaust air plenum. The exhaust airflow design is critical to minimize turbulence in the work zone and to prevent fume from escaping through the sash. The exhaust plenum is designed with a gentle transformation and tapered shape, which limits differential pressure and results in an efficient exhaust air process. An exhaust air damper is fitted to the exhaust duct to balance and set the airflow to safe set point values. The superstructure. The superstructure design has been a process of development established over a period of more than 12 months because there are so many factors that had to be considered and tested before finally being approved and released for manufacture. The casing material is manufactured from electro-galvanized steel and epoxy-coated to provide an aesthetically pleasing product with long-term chemical, abrasion, and corrosion-resistant qualities. Computational fluid dynamic design principles were used to ensure that the entire entry zone into the workspace prevents restriction and turbulence. The gentle tapered air entry shape eliminates vortex airflow patterns. The casing side panels are of a double wall design to house the gas and water services as well as connections to electrical plug points, on-off switches for lights and fan, as well as optional airflow alarm system. The angled casing design enhances ergonomics with excellent all-round vision into the work zone. Airflow alarms. Fume extraction cabinets are safety devices and designed to protect personnel and equipment in the laboratory environment. Low or no airflow conditions may not always be noticeable, particularly when the contaminant is odorless. 2 optional alarm systems are available with audible and visual properties to warn operators when risks of chemical exposure exist due to reduced or interrupted airflow conditions. FiltaMatix fume extraction cabinets can be fitted with state-of-the-art touchscreen airflow monitors specifically designed to make airflow safety easier than ever. The full-color LCD touchscreen displays airflow values and allows end users to configure alarm features for velocity sensing, temperature sensing, response time, alarm volume, relative humidity, night setback settings for energy savings, password protection. This initiative and mission-critical instrument has been engineered with the sole purpose of creating safety and includes a USB port for automatic software updates. In the alternative, a more cost-effective but equally efficient model can be selected. In this instance, the operator can rely on audible and visual alarms at precise set point values for low or no airflow conditions. A night setback feature is also included. Airflow alarms are mandatory in most European countries and optional in South Africa. Maintenance and testing. FiltaMatix employ internationally trained technicians who are qualified and competent to test and validate fume hoods for compliance and continued compliance to recognized international safety standards. Repairs and maintenance are done speedily and efficiently to restore functionality and to minimize work stoppage on site. Perchloric acid fume cabinets. Perchloric acid fume extraction cabinets have been designed specifically for perchloric, hot nitric, and routine perchloric acid applications. It features an all-stainless steel internal work chamber with coved corners around the work surface for easy cleaning and to prevent a buildup of contaminant. An internal washdown system positioned behind the baffle has been engineered to remove 95 to 98% of potentially explosive perchlorate salts. The countercurrent gas-liquid contact results in excellent removal efficiencies of most water-soluble acid and base-laden air streams. Increased emphasis is being placed on improved environmental protection, and for this reason, more and more end users are considering the use of scrubbers, which are fitted to the exhaust system of their fume extraction cabinets. Exhaust fumes laden with contaminant enters the scrubber and passes through a packed bed situated in the bottom chamber before passing through a liquid spray section and mist eliminator in the top chamber. The water from the cabinet washdown system will drain into a separate sump where it is recirculated by a pump and returned to the cabinet. The sump pump station is generally positioned under the fume extraction cabinet and can be enclosed in a storage cabinet to create an aesthetically pleasing installation. A chemical dosing system with fresh water makeup can be included to maintain optimum pH levels. FiltaMatix, a proudly South African company committed to earning your trust.